Hi everyone, my name is Dean and you're listening to the MLOps podcast. As you probably know, machine learning in general and data science are two fields that are evolving all the time, and it's really hard to keep up to date. Specifically, the area of bringing machine learning into production or into the real world seems like it's very confusing. There's a lot going on and it's hard to make sense of all that's happening around you. But on the other hand, there are a lot of smart people that are doing great work in bringing their own projects into production. And we've had a chance to speak with a lot of these people, but it definitely seems like the information is not widespread enough and a lot of people don't know of best practices and how other teams work. So that's why we decided to start this podcast, where we'll be speaking with people who are working in various types of machine learning teams and hearing about how they are bringing their projects into production. I hope you find this interesting, and let's get started. Hi everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have Ran Romano with me. Ran is VP Engineering at an exciting MLOps startup called Qwak.ai. Before that, he led the data and machine learning engineering team at Wix, where he built a really impressive end-to-end machine learning platform. He also has a master's degree in computer science. Hi Ran, really thank you for taking the time.
Sure, no problem. Thank you for inviting me.
Yeah, let's maybe start by giving us a bit of background on how you got into the world of machine learning and machine learning engineering specifically.
So my background is in data engineering. That was kind of my profession at Wix. This is what I started with. And in my first degree, I started getting into more and more into machine learning. Took some courses. So Andrew Ng's course, Stanford's Andrew Ng, and I really liked it, but didn't really want to be a data scientist. Okay, I really liked kind of both worlds, both the engineering and the data science. So when I came into Wix and I had the option to do things in between, to be kind of the engineering front end of the data science group, that felt like a really good match.
Interesting. So where do you see sort of the border? Because there's obviously a lot of talk about titles today. Like you have the data scientist, you have data engineer, now you have machine learning engineer. Where do you see the line between these, and where did you put yourself in when you had the choice?
So that's a really great question. When we started off at Wix with the entire machine learning platform, machine learning infrastructure, basically there was no really title called machine learning engineering. So what I called myself or the team that I built was actually machine learning infrastructure. Same for data infrastructure, actually. Like the title was software engineer slash data infrastructure, software engineer slash ML infrastructure, because this is what we did. We didn't really build the models themselves. We didn't really build kind of the systems around the models. We built an ML platform. We built a system. We built a product that is designed for data scientists to bring their models to production better. So in my eyes, I called it machine learning infrastructure. These days, you have kind of the border between data scientists and machine learning engineers, right? People that only build models and people that need to put them into production. Kind of the handoff. So I didn't really see it that way.
Do you think that there's a clear trend there? Like in the future, will most data scientists become machine learning engineers as well? Or do you think that it's going to be more and more separated?
I think the trend right now is that it's becoming more and more separated. We are seeing actually more and more companies hiring machine learning engineers. And will the trend stay? That's a good question, because it might be the case that, let's say, like software engineers and DevOps, that software engineers are the ones that bringing software into production, and it's not like they're handing off their code to DevOps engineers. DevOps engineers are working on the infrastructure. So maybe it will go to that direction. This is kind of what I personally believe in, but again, not based on some actual data. Becoming that there will be people that will build more and more of the infrastructure with better tooling. I hope so, and the data scientists that will be responsible, that I think will be responsible for also deploying the models to production. that separation between data scientists that only needs to build models and machine learning engineers that only need to put those models in production, I don't know, mixed feelings.
Yeah, no, I understand. I think it's a good distinction, because a lot of times it's sort of it feels like the discussion becomes shallower, saying either data scientists should do everything and be superhuman, or they only need to do like research and everyone else will take around them, like take care of the dirty work. And it actually makes sense. Like DevOps don't do the hard work of bringing software into production. They build the infrastructure that lets the software developers do it. So possibly, data scientists. So possibly it's not a contradiction. Like data scientists will look more like what we imagine ML engineers are doing today, but also you'll have some ML ops, or again, like ML infrastructure building the tooling for them. That makes sense to it. Yeah.
This is kind of the trend that I specifically believe in. Again, it really depends on the tooling. With better tooling, with better methodologies, I think it might be the case. It's really hard, I think, to scale a ML in the organization that way, that you have a data scientist that needs to hand off his project to an ML engineer that needs to put it in production, build an API, and build monitoring. We're already seeing in a lot of companies, like I did in Wix, people building automations around that, okay? Because being a machine learning engineer that needs to take code that he didn't write, models that he didn't write, and put them into production, something a bit tedious.
Mm-hmm. Yeah.
So I think the trend will be automation and ML infrastructure.
Yeah, that makes sense. I think it's also like a good mental model for people that are listening and are trying to sort of imagine what data or ML organization they need to build within their company. Like you need to have people that are making the process itself smoother, but you can't shift all of the work of doing the process to those people. So if you're building your data teams, maybe the takeaway here is you want to hire not just either data scientists or ML engineers, but you want someone who's actually in charge of building proper infrastructure and fine-tuning and optimizing those processes. So that's awesome. Is there a specific part in this entire process of sort of taking machine learning models into production that you're especially excited about, or that you were especially excited about and led you to your current position, maybe?
Yeah. So I think two parts I'm really fond of. One is how do we model, basically a CI/CD system for ML. This is kind of what I really started off at Wix. Okay, we had a really big problem of this handoff. We had a group of 30 data scientists, 25, already don't remember the exact number, and that needed to bring more and more models into production. Okay, and we only had a small group of let's call it machine learning engineers. Okay, they were software engineers, but today they are called machine learning engineers. So that handoff procedure, being a data scientist that was dependent on the software engineering part, was a real issue for us. Okay, so we wanted to automate this process. Okay, it's simple, again, just like we do for software engineering. So the question is, how do we model the same structure, the same methodologies, okay, but including ML special parts, integrating with data sources and everything else. So how do we model this process, the CI/CD process, to make them as independent as possible, to make the data scientist as independent as possible, to bring that they will actually hit the deploy button, and they will put a live endpoint into production. So this is something that I really worked hard on for the first year or something like that, while building the ML platform, the entire CI/CD. It wasn't just, let's say, the tools, it was also the mindset, okay? Because these people were not, most of them actually were not software engineers. They were more statistics background, physics. And now you come to them, listen, everything needs to be version, everything needs to, we need to understand what's in production. So it's a shift. Okay, no more Jupyter notebooks, or no more Jupyter notebooks in production.
Half of the audience now has fire in their eyes.
My opinion.
Yeah. No, I mean, I tend to agree, and I think like this is a recurring theme in this podcast, and I think, I mean, it's meaningful. I think that nowadays there's definitely a clear shift. Like when we started out DagsHub like 2 years ago, Jupyter notebooks in production were a real sort of contentious topic. And now I think it's pretty clear that most organizations are understanding that it's a great tool for some things, but bringing models into production is not one of those things.
I actually tried that. I actually tried building kind of the CI system based on the paper mill. Like there's a famous series of blogs that Netflix wrote about productionizing Jupyter notebooks. So I really like that. I really like the ecosystem. I really tried to do that, but it didn't work out very well. It wasn't really something that that held in production scale.
Was there like a specific reason? Like if I'm now a company that is trying to bring notebooks into production, what should I notice that will tell me that this is a bad idea?
I think paper mill as a tool was great, but I think the viewer wasn't that ready, and it felt like the entire process was really immature. And this is what I remember trying it out.
Interesting. So yeah, you have a lot of hands-on experience.
I don't remember the specific, but it was something like a project that I personally believed in, like productionizing notebooks. This is how we're going to model the CI system. Every model build, every model CI procedure will end in a notebook with nice visualization, but it didn't really, it wasn't really valuable. Like the flexibility of a Jupyter notebook when integrating with, I don't know, other production system was something that really bugged us.
Interesting. So you mentioned the word CI/CD, and this is actually just something that comes up to my mind because there was a discussion about this a week ago. Some people are saying that CI/CD is sort of not necessarily, let's say, an appropriate mental model for machine learning. I feel like you probably are more qualified than many people to talk about that. So what was the conclusion? Like how did you manage to build a CI/CD system which is focused on machine learning?
So let's say CI/CD is a very broad term. Okay, so let's say CI, what I imagine is important for CI is model versioning, is data versioning. This is what we really wanted to build. We wanted to get to a place where we can reproduce every model that is now running in production. So we versioned the models, we versioned the data pipelines. This is kind of the most important things in the CI at least that we thought of as the CI procedure for machine learning. Okay, build for ML, I imagined it as something that runs tests on your model, tests that the data scientist provided, that trains your model. And this is kind of maybe not mandatory or not standard to train the model as part of the CI process. This is something that I personally believe in, but again, I understand the cons. Serializing the model and pushing it to some repository. So what's very different about, what's wrong about this procedure for ML? I didn't see any trouble doing that. Okay, thus you have let's say one command, build command that takes your model from Git, takes your model from the local directory, builds it, trains it, versions it, does all the serialization, and pushes kind of the Docker. We use Docker, pushes not the pickle, but really something that is deployable. So this is a CI system, full-blown CI system for ML.
Nice. So I am biased, but I agree with everything that you said, especially like the focus on like coming to the CI mental model from the point that models and experiments should be reproducible, and then that they could be automatically built, and then that they could be automatically pushed to production. That makes sense. And I agree that like I think most of the opposition to CI/CD for ML is just a terminology issue. Like definitely there are going to be differences from software, but there are differences from software in every like other, I don't know, like software is also a broad term. There are a lot of different types of development and you have different types of CI. So it makes sense that you'll automate that at some point as well.
Yeah, I agree. I think the important part is automation. Again, automation, specifically, we wanted also reproducibility. But for all the models that we have, we also had automatic, let's say, training and deployment pipelines, because we didn't really want to build and deploy those models manually each and every time for every model that we built. not for every model, but for a lot of the models that we built, we also had, let's say, Airflow DAGs that built and automatically deploy the models on a weekly, daily, some scheduling policy. You can't really do that without some notion of a CI/CD system. Okay, I'm not sticking with the exact DevOps like CI/CD, but yeah, CI/CD is a concept.
Mm-hmm.
Something I still strongly believe in. I saw the benefits, let's say.
So I guess there are a few questions, but when you joined Wix, did you join specifically to build out this team, or did you join as like an individual contributor and then the team was formed?
No, I actually joined as an individual contributor to the data engineering group. And as a data engineering group, as part of the data engineering group, I saw, and my boss at the time saw that we were really having trouble scaling the ML. Okay, the data science team lacked kind of the skill set to build these things themselves, and then we started the project. So it was much more of an initiative, of an individual initiative, let's say, than something bought. Okay, let's build an ML platform because data scientists need to scale their models. It usually doesn't go like this.
Yeah. So did you need to do work to convince people that it makes sense? So, like, what tips do you have? If
most of my work.
Well,
no, not most of my work, but yeah.
But I mean, if someone is now like a data engineer in a company, obviously there's a scale issue in the sense of if you're a really small startup, and there are like 2 data people, you probably don't need a MLOps team at that point, but maybe you need to start learning the MLOps basics. But if someone here is listening is a data engineer in a larger organization, again, what should they notice so that they need to start like raising the flag, like maybe what we need to solve these issues is an ML infrastructure team, and how do you recommend they convince the bosses?
Okay, so I can say that from my experience, one of the first troubles that we saw was scaling. Right, it was really taking the first model or the second model to production took a few months, but also taking the 5th, the 6th, and the 7th model to production took the same amount of time. Okay, the problems remain the same. So this is kind of where we started seeing a problem that we need the same amount of time for these, let's say, repetitive tasks. This was one thing, okay, that we noticed, kind of the clear thing that we noticed. Another was more related to the data pipelines issue, more of the feature store. We really had troubles deploying models online. Okay, batch was kind of a lighter issue, but deploying models online, using them as REST endpoints, for example, modeling the same data pipelines that are used for training that we now needed to model them in production was a really big task. That took a lot of the engineering effort. Okay, and really coupled the engineering and data science team together, because every change in the data pipeline, let's say feature, okay, that's feature equals the data pipelines in that case. So every change in a feature data scientists wanted to do required an integration effort. Okay, from the data engineer, the machine learning engineer, doesn't really matter. And this was something that really held us back, because there was a certain amount of features that we could use. Data scientists couldn't use 100, I don't know, hundreds of features in his model because no one could have extracted it for him. Okay, so automation of these automatic extractions of data pipelines, what is called today, the training serving skew. How do I use the same data? Am I trained trained on? How do I use it? How do I get it in production? This is also, this is why we build the feature store, which is a really big part of the MLOps platform. Kind of the hardest part, I would say.
So maybe to share a personal story, the first time I saw you, there was a meetup at Wix in the Tel Aviv harbor, and there was, I think, another talk from Databricks before or after you were speaking, but I remember like listening to you explain about the sort of architecture of the platform that you built. And this was like for us, it was the early days of DagsHub. It was me and my co-founder Guy. We went to a bunch of meetups to mingle with the community in Israel. And I remember like finishing the talk, we went up to ask you a few questions about what you built. But afterwards we were speaking like, man, they built so many things. It sounds super impressive. I wonder how how it actually feels to work with that in sort of in reality. So first I'll ask, what part of the platform that you built are you most proud of?
So again, I think the two parts, kind of the CI/CD pipelines. I think at the end of the time, we really nailed it, and I think the evidence was kind of the amount of models that we had. And we started off with 5 models, 6, 7 models in production at the Qwak, and after a year, something like that, we had something around 300. So because it was that easy, okay, and I remember asking where were all that models? Okay, what did you do? So because it was really easy to model, to have another model and another model, another model, it was just another API, it was just another endpoint. So I was really proud of that, and the feature store. I think it was a very engineering-wise, it kind of the hardest task, the hardest piece to model right, and we really had almost 0 references for something, a feature store. We read bits of articles here and there, but it was something that was really, it was really hard to build, really hard to get right.
Interesting. So
specifically, this training serving skew, again, specifically generating the automatic data pipelines between training and serving. This was 50% of what we did at the ML platform.
Yeah, so I guess the first the takeaway from that is like one metric, if you're the ML infrastructure team, is you want to show growth in the amount of models in production. Like if you can show that, then you proved your worth.
Yeah, it's a tricky metric because measuring infrastructure is always a bit tricky. Measuring infrastructure that is used for anyone else, because what exactly do you measure? You measure, again, amount of models. This is something that I really thought about. How do I measure the success of my team? How do you measure the success of an ML infrastructure team? The amount of models, the amount of I don't know, the amount of predictions. These numbers are not actually up to me in a way, let's say. But again, I think the amount of models and the simplicity, and we actually defined it at the end of the day as time. We wanted to kind of have a data scientist build, deploy, and have eyes on the model in something like an hour. Okay, instead of a few months that we saw right now, we wanted to have that up until an hour. But it was really hard to measure it directly. But I think at the end of the day, it was a successful project. Yeah.
Yeah. I mean, I agree. There's metrics. Metrics are always problematic because you don't know if people don't start optimizing for the wrong thing once you set the metric. I think it's Graham's principle. Guy is better than this than I am. But I mean, in a sense, if there's a real need within the organization to productionize models, and then you made it easier, then you would expect growth in the amount of models in production. So that makes sense. And then maybe the other buzzword that has been said here a bunch of times is feature stories. So I know that what you did is really impressive, but obviously today in the market, this word is thrown around a lot. So first, maybe can you define what a feature story is in your opinion? And then maybe we'll dive into it a bit more.
Mm-hmm. So I can easily define what I wanted the feature store to be. Okay, when we first started building that. So first of all, we wanted to have kind of a single curated and some sort of discoverable source of truth for features. We imagined it as a data catalog for features, and because the problem we set out initially to solve was the problem of data set reproducibility, let's say, because we had a problem. Let's say one of our models that we constantly worked on is that in every iteration of the model, every now and then a new data scientist came and started working with this very important model for Wix. And he started from scratch. he went through all lines of SQL that model features, and in some cases, the tables that he read from were there. In some cases, they were changed completely. In other cases, he didn't understand how to reproduce the data sets. So kind of the feature engineering part or the feature extraction part for training, just for training, let's say, was something that we wanted to solve. So this is what we started with, kind of a data catalog for feature. This is how you model, this is how you now model a feature. This is how the feature is interacting with our data lake. Okay, really a structure for a given feature. So this is kind of the first thing that we wanted to solve, and this made sharing features between projects much more easier, because one data scientist defined a feature for his model. Let's say in Wix's example, how many times did the user clicked publish on his site in the last, I don't know, X days, 7 days, something like that. So this feature was reused in another model. Let's say the churn model and the premium model. Johnson, this is kind of Wix is a freemium-based company, so we have churn, we have premium subscribers, and it's kind of a lot of the models that are used for this model are for the churn model are also good for the premium model, for example. So this was the first thing we set out to solve, the single discoverable source of truth, and the second was this training serving skew. How do you make these features that data scientists trained his model on? How do you make them accessible in production? Okay, so this is what I wanted the feature store to solve.
Okay, so I tend to agree with that terminology. I feel like usually when you now look at the solutions for feature stores that you can buy, usually they do a better job at solving the first part, and then most of them sort of don't really live up to the second standard, which I think I mean it's sort of objectively harder to do. Yeah, so first
from experience.
First it's impressive that you succeeded in doing that. I guess everyone usually refers to like the Uber platform, right? Like Michelangelo, that's the reference that people usually use, but that's obviously not open source, at least not as far as I know. And so one question that I have about this is, doesn't this require, like, what part of the success of this part of the second feature, so again the training serving skew, is solved by workflow? So you need to convince the data scientists to work in a certain way in order to get this result. And how did you manage that within the organization? Like, I don't know how many data scientists Wix has, but I'm guessing it's more than a few.
More than a few. So how do I convince the data scientist to use the feature store? This is what you're asking.
Yeah, I mean, or maybe how do you make it so easy that it's not a hard choice for them to do?
So I think it was mostly the second part that was attractive, let's say, for data scientists, because when a data scientist wanted to deploy his model into production, okay, we had a system of the feature store was actually really integrated into the ML platform. So when a data scientist built his feature and then kind of declared it in the schema of his model, then the platform would auto extract it for him. And then he was kind of decoupled from the engineer. So we didn't really have to talk with anyone to deploy his model. He didn't have to talk with anyone, to get the features for him. So this is what was really valuable. Okay, this was kind of one of the main reasons they started using that, because kind of the organizational perspective was, listen, we're not going to extract any more features for you. You have a clear way of how to do that. You want to deploy models into production. You want to use hundreds of features in your model. So this is the way the feature store is going to solve that case. Otherwise, you're going to get stuck in integration. You're going to need to have favors, to ask people for favors that extract the features for you. And the feature store really solved that. So this is what was a sweet spot. You want more features in your model. You want to use clever. You want to iterate faster. You want to be more independent. This is the way to do that.
And your requirement from them was just to sort of fulfill a contract, like build out the feature as an interface?
Build out the features as, use the SDK that I gave them. Now, it wasn't really easy, okay? Not everything was modeled, could have been modeled using the DSL. So a lot of the ping pong was, okay, I need these specific set of features, or I need these aggregations. So a lot of what we do is okay, how do we support these? We call them feature families. How do we support feature families that are based on the site content, of the Wix site itself? How do we base features on data that we saved in Snowflake? And we always wanted to offer an infrastructure for that. We didn't really want to pull this specific feature or that specific feature. We always, as an infrastructure team, again, this is what I considered myself, or considered my team, an infrastructure team. We wanted to solve the general problem. How do I model features from Snowflake? How do I model features from that source, or other source?
So once the initial platform was built, most of the work was sort of building connectors for more data types and things like that. Yeah,
building connectors for more data types. A lot of time we spent on the performance of the feature store. Again, I'm not sure how technical do you want me to get, but the way that we built the feature store was that a feature was not actually materialized. This is something I see in feature stores today. We had at Wix 5,000 features, okay, but there wasn't 5,000 ETLs computing these features all the time. So feature was only a concept, or only a metadata once it was created. We only manifested it, and we only made it materialized once a data scientist requested to generate a training data set. So basically, a feature was just, let's say, in the offline world, in the training world, was just a Spark SQL. So a feature translated into Spark SQL that we invoked on the data lake once the data scientist requested to generate a data set. But again, because features were not pre-computed, so the trade-off was time. Okay, if nothing is pre-computed, if everything needs to be computed on the fly, on Wix data lake scale, so this was a big issue. So every training data set, we invoked a really big Spark cluster, and a lot of what we did was performance optimization. What is the sizes of the Spark cluster? What is the compute power needed to generate the training sets in viable, meaningful times? That sort of things.
But doesn't that also risk losing reproducibility if you are like you need to ensure that the underlying data isn't changing, right? So did you work on that?
Yeah, underlying data doesn't change. So this is kind of a guarantee of how the data lake at Wix is modeled. Okay, the data lake at Wix is very, very organized. We have a specific catalog of how data is inserted. So no one is changing that. It's immutable. It's append only and immutable.
Interesting. So
the ML platform was built on top of the data platform. So we had a lot of the data infrastructure, the data tools that we used at our disposal. Okay, we really built the ML platform on top of the data platform. It was really mature at that point.
Yeah, interesting. So these are all good tips, sort of, if someone is thinking about building their own equivalent solution. I guess
data is first.
Yeah,
data is definitely first.
You need to solve for data, and then you can solve for machine learning. Do you think that there's you built this very sophisticated system, and I think you gave us a few examples of the metrics that prove that it was useful to the organization. Is there some criteria you'd say for someone who's listening that they shouldn't build such a thing? Specifically, the feature store seems very complex. So when do you think it's not necessary, or when is it too early to build out this thing?
I think it's too early to try to build yourself, okay, an ML platform. If you only have 1, 2, or 3 models, or these models are something that you need to really tweak, kind of to build the entire business on. So it was a generic platform. Okay, and it has drawbacks building such a generic platform. Again, we had to work hard to add connectors, to add the frameworks that we support, to add all of these things. So having a generic platform for all the models in the organization has a drawbacks, of course. So if you need, a very few models or something very, very specific, you want to build, I don't know, an entire recommendation system, from scratch, and you need it with specific, very, very specific requirements, then I'm not sure building an MLOps platform and then writing your very complex, I wouldn't say model, but ML system on top of that is a good idea.
Mm-hmm. Okay, fair enough. And one of the things is like for me personally, I guess for us at DagsHub as well, the open source is sort of a very close topic to heart. And obviously, like in machine learning, everyone is using probably one of the TensorFlow, PyTorch, or sklearn, which are all open source packages. But even when you go into the realm of ML tools and ML platforms, you have open source solutions. So I'm curious to hear, like, within the platform that you built, what parts did you decide not to build? Did you use open source solutions to sort of fill in the patches, and how did you choose the tools that you used?
Mm-hmm. So the two main tools that we used, and again, it's a bit of a tricky question because that was 3.5 years ago, something around that. So the ML tooling community, or the ML tooling, the ML tools that are available today weren't really available back in the day. I think I was the first user, at least in Israel, first user of MLflow. This is kind of the early days of I wanted to build the platform. Then I saw, I came to London, I went to the Databricks convention, and I saw MLflow, and I said, okay, this is how I'm going to solve the serialization issue. This is how I'm going to solve the experiment management. This is how I'm going to build, basically, build the CI system on top of. This was, I think, a naive idea at the time, but it worked. Let's say it required a few iterations, but eventually it worked. So
why was it naive?
Because it was really, again, I think I was the first one to use, one of the first to use MLflow in production. I would dare say that, and it was really immature again. And we had to customize the hell out of MLflow, basically. So maybe using that project, for what we saw as an MLOps platform for Wix at the day, I don't know,
It was a leap of faith.
In retrospect, everything. Yeah, it was a leap of faith, and eventually paid off, I think. But again, the road wasn't easy. So we used MLflow for experiment tracking. We used it to build the CI system on top of, and we used SageMaker as a hosting mechanism. And this was two of the main tools that we used, and Spark. Spark is the offline feature store, okay, or the offline feature store engine, based on our data lake, on Parquet's on S3, and for the online feature store, it was Redis.
Redis, okay. So a few open source.
This is kind of the main, a lot of open source.
Yeah, interesting. So you.
But
yeah, sorry.
Continuing that question, so stitching together these open sources, and that kind of maybe leads me to why Qwak, or why I left to build Qwak. Stitching these open sources together, kind of building an MLOps platform on top of these and other tools was a really big task. Okay, and it required a lot of resources. It required kind of a full team of 6, 7, 8 people, depending on how you on which period of time. So building a team of 8 people to build an MLOps platform for your organization is something that Wix started having these problems early. So we kind of had to build it. But I don't think that's I don't think that should be the way to go today. To build your own MLOps platform from scratch, that's a big thing to do. if that's not your main business.
Yeah, that's a fair statement, and I think that patching together, the disparate parts and making sort of, there's a lot of knowledge to inject into that patching together, because things need to not just work on the same, I don't know, Kubernetes cluster or whatever you're running it on. It actually needs to have a logical interface so people can transition between those stages of the process logically. But I guess
this is the main point, actually, what you just said. This is the main issue.
Mm-hmm. So yeah, I guess this is a good segue. So maybe can you share a bit of what you're working on at the moment?
Mm-hmm. Sure. So I'm at Qwak. I'm the VP engineering and one of the co-founders of Qwak. And what we're building is basically an end-to-end MLOps platform. And similar to what I had to build at Wix, to what our CTO, Yuval, that saw it from SageMaker side, or Alon, our CEO, that came from Payoneer, was the VP data of Payoneer. All of us had to kind of reinvent the wheel in different places. And I think it shouldn't be the case anymore. Okay, I think in this time, building an MLOps platform for your organization is something that we want to help companies do.
Okay, interesting. So when you say end to end, like where do you draw the lines? Like, do you?
That's a good question. Okay, so when I say end to end, the lines that I think, or at least let's say our areas of focus right now are the CI/CD part. Okay, how do you build more models faster and deploy them into production? That's kind of the mission statement as I see it for the CI/CD. And the feature store, which I think is really an integral part of what an MLOps platform should include. Because it is the hardest part of building an MLOps platform, especially in online models, in real-time models. And I think the trend is going there, building more and more real-time and models. So I think a feature store, specifically training serving skew, is something that an MLOps platform must have.
Okay.
We have two notions in Qwak. So we have two first-class citizens. One is a feature, and second is a model. Okay, and it's a many to many. The idea is that you can see in the model which features are being, which features is the model using, and same for a feature. Okay, this feature is being used in which models. Having a feature store alone doesn't allow you this level of discoverability or this level of integration. I can say in Wix, when a data scientist needed to build a new model, so the first thing he did, and I know that from experience, was going to the feature store and seeing what other models or models that he think is similar, what features are they using, and then he kind of built the first version of his model. Oh, so this sounds like an interesting feature because this and that model are using that. This sounds like a very interesting feature. So he had a very rich ecosystem of features. He just had to to pick and choose which features are you going to use this model, generate a training set, and see how it goes.
Yeah, that's I mean, that's super interesting. And also, I think, I'm guessing like what you're talking about is very oriented towards tabular data, right? Because then people are looking at the model and sort of choosing the feature calculations that they need, and then it's being pulled into the model. So this is something that we're thinking a lot about at DagsHub as well, but more in the realm of unstructured data, and how do you do that?
Actually, a feature store for unstructured data is also an interesting concept.
Yeah,
feature store, embedding feature store or feature store for
I think it's definitely something that's it's earlier, let's say, in the life cycle of unstructured feature stores, but it's something that we're thinking about, and really, how do you, like, what does it mean to do all of this work of, I have this model, I want to be inspired by it, to understand what the smart people that came before me did to create it, and then hopefully improve it, because everyone has something to contribute, and maybe you're looking at the problem from a different perspective, but you have to have that context. So I definitely understand what you're talking about. One sort of trade-off that we've seen come up a bunch of times, and I'd like to hear your perspective on, is like end-to-end versus, I don't know, you would call this integrated or something like that. So So you said that your choice was to go after sort of an end-to-end solution. How do you view this trade-off? Like when is this solution better? When is the other option the right one?
Mm-hmm. So I think, it's a question of, again, best of suite versus best in class, let's say, for example. And when you're really trying to build an ML platform that you really have kind of, you're starting off with your ML journey, and you need to build now an ML platform, you need to build some parts of a feature store, you need to build some part of a deployment mechanism, some part of the workflow orchestration. Trying to get all of these, components together and glue them is something that can be, very hard to do. Again, I know that because this is what I had to do. So you need a team to build that. You need personnel. You need people to glue that thing together into a platform that makes sense for the organization.
Yeah, makes sense. So, okay, Ran, thank you very much for your time. It was a pleasure having you here, and hopefully we can talk again in the future.
Yeah, of course. You're great. Thank you, Dean. Thank you very much.
Bye, everyone. Thank you for joining.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again, and see you next time.